Thank you, Matei, Clemens, and Sean. And it looks like we do have a few minutes for some question and answer with Matei, Clemens, and Sean. So, gentlemen, let me read off some questions for you. So the first one is for Matei. Which components of ML Flow, Matei, are the most widely used?
So the most commonly used and the one that people start with is usually experiment tracking. But after that, we also see a lot of use of model packaging and the model registry as a way to share models and keep many versions of them around and send them into different deployment environments.
And the next one is for Clemens. So generally, people are curious what's next in the roadmap in the areas of model governance and the model registry.
Mm-hmm. Yeah, so on the model registry, there's a couple of interesting items. Right now, we usually start with an API-first approach. And as actually mentioned earlier in my talk, we have some customers that actually use the model registry to train tens or hundreds of thousands of models and deploy them. That requires a lot of sophistication, and they use our API surface to manage that CI/CD pipeline. So we're slowly making that easier, and we're actually planning to provide hooks in the model registry so that you can more easily integrate the model registry with your CI/CD systems and manage the deployment lifecycle of these models. So in short, I think a lot of the work that we are investing here is to making it more accessible and more easier to actually manage the MLOps lifecycle in the model registry. And then there's also a couple of other bigger roadmap items that I'm not going to tease here. We're actually going to talk about them at the Spark Summit in June.
Another reason for you folks to sign up for the Spark Summit in June, which is online and will be free. The next question is for Sean Owen. So Sean, how does the notebook integrate with system hardware? So someone wants to know, for example, GPUs and CUDA integration.
Yeah, right. On Databricks, Databricks is going to manage all the hardware for you. So when you start a cluster, you can, if you like, choose a version of the runtime that supports GPUs and provision GPU instances, and everything else is taken care of for you. So CUDA will be installed, TensorFlow will be installed for you if you're using the ML runtime. And even more than that, Databricks will do things like, if you like, scale up the cluster and scale it down according to load, and even shut it off when it's not used. So you generally don't have to worry about the hardware or getting the libraries installed. That's done for you.
So the next question is for Matei. And Matei, generally speaking, one of the areas that people consider to be a main bottleneck, at least particularly for deep learning, is distributed training. So how does one go about distributed training of a machine learning model that is not ML lib-based in Databricks?
Yeah, great question. So we do support distributed training of TensorFlow using the Horovod package and also using the distributed training strategies that are coming out in TensorFlow itself, in TensorFlow 2.0. And it's also possible to do this for PyTorch. PyTorch has been adding more support for distributed training as well. So we've done a bunch of work to make sure that the machines are configured with high-performance networking and with high-performance shared file systems so that your distributed training job can run on them.
Next question is back to Sean. Sean, if all the modeling steps are being done in the notebook setting, so how do these transformations get tested? So how am I sure these transformations are ready for production?
Yeah, great question. I mean, obviously, you want to test your model in some sense before you turn it live. So Databricks supports that in a couple ways. Number one, a notebook could encapsulate some testing code. It could load a model. It could run some smoke tests, test it against a golden set. And that itself could be scheduled through a job in Databricks to run regularly, or indeed could be triggered from an external system like Airflow or Jenkins if that's the tool you're using to orchestrate and run CI/CD. So I would view Databricks as a place to run code that can be triggered, can be run from many different places flexibly.
Next question is for Clemens. does HyperOpt in Databricks differ from the open source version? And Clemens, you might as well explain to our audience in general, if they're using an open source tool, say TensorFlow or PyTorch, how do the version in Databricks differ from what's available?
Yeah, that's a great question. So in general, we really want to provide you with the best open source tools on Databricks and just make sure that they work out of the box. So the short answer is when you use something like TensorFlow, PyTorch, or HyperOpt on Databricks, the libraries and packages themselves are not different. So like we're not changing the APIs, or like we're not changing the way that you used to be using them in other environments. Now, in addition to this, we usually provide improvements in some cases in performance, or in like distributing these workloads on Databricks. I'll give you one example specifically for HyperOpt. So the HyperOpt API itself is exactly the same. We just package it up with the machine learning runtime so that you don't have to install it. But then we actually extended HyperOpt with this functionality that Sean showed earlier that's called the Spark trials. And that actually allows you to distribute your hyperparameter tuning trials using Spark. So like each one of the Spark workers just runs a trial in parallel. And that gives you a performance advantage. So we usually provide the standard APIs, standard open source tools, and then provide additional benefits on top of them.
Next question is to Sean. So Sean, in addition to notebook-based model development, can someone also leverage Databricks to implement CI/CD best practices? So this is Git, build and deployment pipelines and so on, to automatically retrain and verify models on a schedule?
Yeah, I think a similar answer. So if you've got some code in a notebook that trains a model, you can trigger that on a schedule easily with something like the job scheduler built into Databricks. You can also train it externally as well, or trigger it externally through a tool like Jenkins or Airflow. And the MLflow in the model registry has a role to play there. For example, if you've registered a new current model as a staging candidate for your production model, you might have a job that grabs that from the registry, from MLflow, runs some tests on it via Databricks, and then updates its state to production, for example, to indicate that this is past tests and this is ready to go. So yes, you can absolutely do that. You can also use Git to back things like your notebook revisions as well, but that's a little bit separate. But yes, Databricks is the place where the code executes and the models are managed, and it can flexibly be run and triggered and driven either internally or externally.
And with that, that's all the time we have for this live Q&A. And a quick reminder, all these gentlemen will be at the Spark Summit in June, so make sure you register soon. So if you want to try some of the things you saw in the previous talk and as well as the demo, go to databricks.com/try, where these tools are available. As a reminder, you can continue to submit your questions via the Q&A panel as we carry on with the presentation.